Welcome back to the deep dive. So, if you've been online at all recently, you know large language models, LLMs, they've kind of exploded, right?
Oh, absolutely. They've really changed the game.
Yeah, and the sources we looked at, Gerardo and Giovanni Iovane, they nail it. These models are a huge step in AI. I mean, human-like text, translation, chatbots. It feels almost like magic sometimes.
It really does. And that feeling, that sort of empirical wow factor, that's exactly where we need to start today, because we're going to do a bit of a reality check.
Okay.
We're diving past those surface breakthroughs. We need to look at the really serious philosophical and frankly practical challenges, the limits of these current LLMs.
Right.
The sources we've got argue pretty strongly that this statistical brilliance, it isn't true intelligence. And maybe it can't be, not without a fundamental rethink of the architecture.
So our mission today is really to get under the hood of that disconnect between, predicting the next word really well and actually understanding.
Exactly. What's the line? And the core problem, well, it starts as philosophical, but it shows up in very real technical failures.
How so?
Well, these models, their strength is finding statistical associations in massive amounts of text. But that very strength, that total reliance on statistics, it seems to block any real semantic interpretation, any real context.
Yeah.
They're masters of matching patterns, yeah, but they don't seem to grasp what the patterns mean out there in the world. And that tension, that's the central challenge for AI going forward, especially if we want AI that's truly grounded.
Okay, let's maybe quickly touch on the architecture. And we know they use these deep neural networks,
Yep.
right? Trained on just enormous data sets. That gives them this amazing ability to generalize across different tasks.
That's right. Generalizability is key. But, and this is the critical part, it's only formal generalizability. The system is just calculating probabilities. Which token is likely to follow another? So when you give them a problem that needs, say, dealing with ambiguity, or some real-world common sense, or maybe an ethical judgment, stuff humans do almost without thinking.
They fall down.
They often fall down hard. The huge data set can sometimes mask this, make it seem smarter than it is, but the core weakness is there.
Okay, but hang on. If these things can generate text that's so accurate, so coherent, sometimes surprisingly insightful, why should we get hung up on old philosophical debates? Like, the grounding problem. Hasn't deep learning sort of leapfrogged that issue with scale?
That's the million-dollar question, isn't it? And the sources we're looking at say, well, no, not really. People like Daskal point out this persistent problem, symbol grounding.
Explain that a bit.
Okay, so the tokens, the words the LLM uses, they aren't actually connected to anything real, no object, no real-world context, no intention behind them. So how can they truly refer to something meaningfully?
Oh, okay.
The system's got this brilliant formal structure. It knows the grammar, the syntax, but it lacks the function. It doesn't connect back to the world.
So it knows dog often comes near bark or walk,
Ah,
but it doesn't have the experience of a dog barking or the feel of a leash.
precisely. No embodied experience, no real-world anchor. And that lack of grounding, that's what leads us directly to the practical failures, sometimes really startling ones, like hallucinations.
Right, hallucinations. That's when the AI just confidently makes stuff up.
Ugh.
The stuff that sounds plausible but is totally wrong.
Exactly that. And the mechanism behind it is simple, but also pretty alarming when you think about it. The model is detached from reality. Its only goal is to make a sentence that looks good, syntactically right, stylistically fits.
Okay.
Whether it connects to anything real or intentional, the model doesn't care. The output isn't for anything. It's just the statistically most likely sequence.
That does sound terrifying.
Okay.
Especially when you think about where people want to use these things, not just for, like, writing poems, but
Legal advice.
yeah, or medical diagnoses, decision support for critical systems.
Yeah.
An output that sounds convincing but is just fabricated. That's a huge risk.
It's a massive liability. And it gets worse because of how we react to it. Largy and Dattery talk about this tendency, they call it the intentional stance, meaning because the output looks so real, so human-like, perfect grammar, confident tone, we, the users, we start to think it actually understands. We attribute intentions, rationality, comprehension to it, even when it's completely absent.
So the very realism becomes a trap. We trust it because it sounds trustworthy, even if it's spouting nonsense like a made-up legal case or a wrong medical fact.
Exactly. But the problems aren't just these outright hallucinations. The models also really struggle with just following complex instructions.
Okay.
They often fail to translate what we ask them to do, especially if it's abstract or needs multiple steps in a specific context.
And there's data on this, right? This isn't just anecdotal.
Oh yeah, solid data. Sheth and colleagues did some meticulous work here. They tested GPT-4, which is arguably top of the line right now, and they gave it a complex set of constraints to follow. The result, it only managed to adhere to all the constraints and wait for it, 0.6% of cases.
0.6%.
0.6. That's a 99.4% failure rate. Near total failure when the task gets genuinely complex, needs adaptation or memory of the instructions over time.
Wow. Okay, let's just pause on that. A 99.4% failure rate on complex but linguistically clear instructions. That really drives home the point that sounding smart isn't the same as being capable.
It really does. It shows this huge gap between just generating language and actual executive function, understanding and acting on instructions properly. And what's really telling is that trying to fix this with instruction tuning, basically showing the model more examples of instructions, only really works for common, simple tasks.
Right.
When the instruction is complex or rare, the tuning doesn't help much, which again points back to that symbol grounding problem. You can't just paper over these conceptual limits with more data or more examples. There's a fundamental issue.
Okay, so if that's the performance failure, let's step back. Why is the architecture itself causing this? Some sources, like Florida and colleagues, suggest it's rooted in an outdated idea of what knowledge even is.
Exactly. They argued that LLMs are kind of built on this old model of knowledge and epistemology that sees knowledge and society, too, as just a static pile of separate facts, like items in a warehouse.
Isolated things, not connected.
Right. And you see this reflected right in the architecture, how LLMs tokenize language. They break it into these isolated bits, sequential tokens.
So the model might see bird, sings, tree as separate data points linked statistically.
But not as part of a dynamic, interconnected reality. It misses the relationships, the history, the context that actually creates meaning for us, humans.
Then human language, human thought, it's deeply social, historical.
Totally. We communicate based on shared understanding, shared intentions, expectations developed over time. LMs just don't have that temporal dimension. They can't really factor in context-sensitive intention.
Which makes them fundamentally unsuited for tasks needing nuanced cultural understanding or real inclusivity, right? If you strip out the who, when, why, you lose the meaning.
Precisely. And that's why just trying to add fixes after the fact, bigger data sets, clever prompts, more fine-tuning, it's probably not going to solve the deep problems.
Like putting lipstick on a pig, kind of.
Well, Musnug puts it more formally, but yeah. He argues you can't just graft ethics or meaning awareness onto a purely data-driven machine.
It has to be built in from the start.
It has to be part of the fundamental design. Philosophies like Sophimatics argue these things, context ethics, meaning need to be explicitly encoded right from the beginning.
Which implies a need for fundamentally different kinds of AI architectures.
It does. But, before we jump fully into the future, we absolutely have to acknowledge the wins. Buckner makes this point clearly. Deep learning has had stunning empirical successes.
Like what? Remind us.
Well, beating top humans in complex games like Go, recognizing objects and images with incredible accuracy, composing music, poetry, even detecting faint signals from exoplanets, or predicting how proteins will fold. That's huge.
Okay, yeah. That's an amazing list. So we're definitely not saying deep learning is a dead end.
Not at all. It's incredibly powerful for certain things. But Buckner adds the crucial counterpoint. These successes often come with big limitations in, well, interpretability, ethical robustness, and real-world long-term usefulness.
Got it. The successes are real, but so are the limitations, especially when things get complex or fuzzy.
Exactly.
So if just making current models bigger or tuning them better isn't the answer, where do we go? What's the roadmap look like?
The consensus building in the research seems to be a shift, a refocusing towards architectures that are neurosymbolic, context-sensitive, and relational.
Neurosymbolic, combining neural nets with older symbolic AI.
Kind of, combining the pattern-matching strengths of neural networks with the logical reasoning and structure of symbolic systems. The idea is to get the best of both worlds. And frameworks like Sophimatics, they provide that philosophical underpinning. They force us to think about how to explicitly build in context, time, relationships. That seems to be the path forward if deep learning is going to really deliver on its promise, moving beyond just sounding smart.
Towards actually being grounded and capable.
Precisely.
Okay, so that brings us full circle. We started with the wow factor of LLMs, their statistical power.
Right.
And we've journeyed through the realization that they lack Grounding, context, relational understanding. It forces a rethink of what we even mean by intelligence in machines.
It really does, and it leaves us with a really interesting, maybe provocative question for you, the listener, to mull over. It's something Largy and Datery touch upon.
What's that?
If these AI systems are built on, let's face it, relatively simple probabilistic models underneath all the complexity, why can they generate behavior that appears so complex and, sometimes, so insightful?
The gap between the simple mechanism and the complex output.
Exactly. And the big challenge moving forward, both philosophically and technically, is going to be teasing apart those appearances from reality. When does an AI just behave as if it understands versus when or if it actually possesses genuine grounded understanding?
That distinction, that seems like the absolute key for the next generation of AI development.
I think it is. That's the hurdle we really need to clear.